The claim sounds simple but dangerous. Tesla built a motor that spins faster, runs cooler, and changes the math on speed and cost. But what if I told you the real story started years ago with a problem no one could solve? How do you make an electric motor go supercar fast without tearing itself apart? Back in the early EV days, motors hit a wall. Spin them too fast, and the rotor, the part that actually spins, wants to fly outward from the force. Metal sleeves bulge, heat builds, bearings suffer. Most car makers limited motors to the mid-teens in thousands of RPM to keep them alive. It worked, but it put a hard cap on power density. That means bigger gearboxes, heavier parts, and less efficiency at the top end. Everyone hit the same limit and called it engineering. Tesla didn't. In 2021, while launching the Model S Plaid, Elon Musk quietly showed the fix: a carbon-sleeved rotor. Think of it like a high-strength belt hugging the rotor so hard it can't expand. Carbon fiber is light, incredibly strong, and doesn't stretch when hot. That belt lets the motor spin past 20,000 revolutions per minute with less heat and more stability. And here's where it gets wild. Speed is not just bragging rights. High RPM means more power in a smaller package with a shorter, simpler gear reduction. It's the difference between using a jackhammer and a scalpel. But wait, this next part changes everything. Building it wasn't easy. Carbon and metal expand at different rates when hot. If you wrap carbon wrong, it loosens or cracks. Tesla had to develop a way to wind the sleeve with the right tension so it stays pre-stressed. That keeps the rotor squeezed at every temperature. It also demanded precise balancing, specialized oil cooling, and an inverter that can feed clean current at extreme speeds. In short, it's not a single trick. It's a stack of small wins. What did that unlock? Numbers that sound fake until you check them. The Model S Plaid does 0 to 60 in about 2 seconds with rollout on a prep surface and quarter miles in the 9s. That's Bugatti quick without the noise, the gas, or the maintenance. Top speed is software limited unless you buy the track pack, where it can clear 200 miles per hour with the right wheels and brakes. And let me tell you this, that pace doesn't murder efficiency like you'd expect. On the EPA cycle, a Plaid with 19-inch wheels is still in the ballpark of 350 to nearly 400 miles of range. In energy terms, you're around 30 kilowatt hours per 100 miles at highway speeds. At 15 cents per kilowatt hour, that's about $4.50 to drive 100 miles. A gas car that gets 30 mpg at $4 per gallon costs roughly $13 for the same distance. Same speed, a third the cost. You thought that was big? Try this. That carbon-wrapped rotor made the motor smaller and lighter, which helps everything around it. Less mass to cool, less strain on the gearbox. Smaller packaging means better aerodynamics and more room for battery. Tesla pairs it with a high-efficiency inverter, using silicon carbide electronics in many models, to cut electrical losses. The cooling loop runs oil through the stator and rotor to pull heat right where it forms. It's like a heat heist. Steal it early, keep power higher, longer. This didn't happen in a vacuum. Roll back a decade. Tesla went from the Roadster's borrowed and hacked parts to the Model S's clean sheet, then to the Model 3's permanent magnet motor that raised efficiency on city driving. Along the way, they learned where power gets wasted, eddy currents in metal, switching losses in inverters, drag-in gears. The Plaid motor is the sum of those lessons. Every watt saved is range gained or heat avoided. And when you can rev past rivals without exploding, you don't need heavy multi-speed gearboxes. You keep it simple and let software manage torque. But it gets crazier. The motor is only half the punch. Batteries set the ceiling. Tesla's 4680 cell was designed to lower cost per kilowatt hour and boost power delivery by using a larger can and a tabless design that reduces internal resistance. In plain words, the bigger shape moves current more evenly, which keeps the pack cooler under heavy load. Not every Tesla uses 4680S yet, and the ramp has been messy, but when the cells hit their stride, they pair perfectly with motors that ask for brutal current without sag. More power out, less heat in, longer life. That's how you get speed and range in the same car instead of choosing one. So why can't everyone copy it? Some can match pieces. Lucid's motors also spin around 20,000 revolutions per minute and are impressively compact. Porsche has strong thermal management and repeatable track performance. BYD wins on price and scale, especially in China. But the specific carbon sleeve method, the winding tension, the thermal tricks, the inverter logic, and the plant that builds it all at volume, that combo is hard. If you get the tension wrong, your rotor shreds. If your inverter loses efficiency at high switching speeds, you leave power on the table. If your cooling is off, you derate power after one lap. The secret is not a part, it's the integration. Let's talk money, because that's where revolutions win. A Model S Plaid has hovered around the $90,000 mark, depending on options and timing. That's supercar acceleration for the price of a German luxury sedan. In running costs, it's even more lopsided. At average US power rates, a Plaid's 100 miles cost about a fancy coffee and a half. Replace miles per gallon with miles per kilowatt hour, and you're looking at roughly 3 to 4 miles per kWh in normal driving. Compare that to a 15 mpg performance SUV burning through $25 of fuel every 100 miles. And because there's no engine oil, no transmission fluid, and fewer moving parts, maintenance drops. Tesla's drive units have been designed for very long life, hundreds of thousands of miles, and the company has claimed million-mile lifespans for some components in earlier models. But what if I told you the quiet part out loud? Performance sells headlines, but production wins wars. Tesla built gigafactories to stamp, cast, wind, and ship at speed. Giant casting machines cut body parts from dozens to a few. Direct sales cut dealer delays and markups. Over-the-air software updates tweak thermal limits, inverter maps, and even top speeds after delivery. That tight loop lets Tesla push hardware harder without a new model year. Meanwhile, most legacy makers built EVs on old factories meant for engines and gearboxes. It works, but it fights the flow. Now, one more twist. AI. Tesla's full self-driving software is still supervised hands-on, eyes up, but its vision-only approach learns from billions of miles of video. The same hardware stack that runs driver assistance also manages the powertrain with precision. Smoother pedal mapping means less energy wasted. Better thermal predictions mean more power unlocked when you actually need it. And while rivals lean on HD maps and small test fleets, Tesla trains on data from the real world. It's not magic, it's scale. So where does this go next? Tesla has said its next-gen drive unit will cut costs and remove rare earth materials entirely. That matters because many permanent magnet motors use rare earths like neodymium. If Tesla hits rare earth-free magnets at scale, they reduce supply risk, cut cost, and dodge geopolitics. Pair that with cheaper packs and the carbon sleeve playbook, and you get a smaller motor, less mass, lower drag, and more cars built per dollar. It's not just faster, it's cheaper to be faster. And here's where it gets wild. The Plaid's carbon-wrapped rotor wasn't the finish line. It was the test case. Track packages proved stability. Software raised limits over time. The factories learned how to make it repeatable. Now imagine that know-how sliding into a mass-market car with half the price and most of the tech. That is the threat, not a single record lap. A million cars that pull like a rocket, sip power like a hybrid, and cost less to build each quarter. Rivals won't stand still. Porsche, BMW, and Mercedes are pushing 800-volt systems for faster charging and lower losses. Lucid licenses powertrain tech. BYD floods the market with affordable EVs and hybrids. And regulators are tightening efficiency rules. The race is not over. But Tesla moved the finish line with a motor that didn't explode when it spun to the moon. The suspense you felt at the start, could a motor end the EV race, has an answer. It won't end it. It will force it to evolve. The carbon-wrapped rotor is proof that small, hard engineering problems decide big markets. And the next chapter is simple. Whoever turns those problems into products at scale wins.